All right, good afternoon, everyone. I hope you're having a good day today. So if you're watching live on Teams, I just want to apologize. Unfortunately, the conference mic that I've purchased doesn't appear to work very well with Teams. By work very well, I mean doesn't work at all. It's kind of ironic because the thing does work. If I go into Audacity, I can record with it. Unfortunately, it doesn't work for Teams, so I'm just going to return it and try something else. So like I say, you shouldn't have a problem hearing me, but hearing the class, unfortunately, that'll probably be a little bit difficult just because the laptop mic's facing me. If you can't hear me, let me know, but it should be all right. Hopefully, the people face-to-face won't have any issues hearing me. That'd be a pretty big problem, but that won't be a problem today. So we're going to be in data modeling today, and if you're following along with the PowerPoint slides, I am going to skip some of the PowerPoint slides. They kind of have redundant information, as well as information that's not really going to be within the scope of this course. So a couple of the slides we're going to be skipping over, so just keep that in mind. But today, again, it's all about data modeling. So we talk about what data modeling is. Well, as the name would imply, it's simply taking your data and putting it into some sort of a representation. We, of course, call that representation a model, but we want to avoid a circular definition. So typically, we're going to do this in a graphical fashion, where we're going to have what our data is. We're going to take it and make sure that we have some way to easily kind of represent that. So within this, there's going to be a lot of different ways to model the data and a lot of different ways to go about this process. So the book talks about the 5W plus H model that we want to, kind of apply to this. And that is, of course, who, what, when, where, how, and why. So, for each of these different things, we're going to have a different model that represents it. So for example, we're going to be focusing a lot today on the what. That is to say, what our data is. We're going to use the data model for that. If you're wanting to look at the time, when is the processes going to take place? At what point do we implement certain things? That's all going to be inside of a PERT chart. Of course, I'm not a big fan of the PERT chart. I'd probably use a Gantt chart instead. But you have the option there on how you choose to model it. So there's lots of different approaches here. Just kind of know that we're going to be focusing on the data model today. So within that data model, there's going to be some things that are very important. The most important part of a data model is going to be the entity. So the entity is going to be the specific noun that we're wanting to collect information about. So for example, if we're doing a student database, we're having information collected about students, or the entity would be called student. And then within that entity, we would have specific attributes of interest. So for example, if we're taking an attribute of a student, it could be first name, it could be last name, it could be student ID, it could be things like, whatever you want to know about a student. Maybe their telephone number, maybe their email address. Just information that you would normally have about a student. Those are all going to be attributes of the entity student. So if we kind of think about this outside of the scope of a model, we think about this inside of a database, the entity is a table. And the attributes are going to be columns within that table. Then we also have a relationship. That is to say we have two entities. There's some relationship between them. So for example, maybe a student takes a class. So the two entities there, we have a student and we have the class entity. It's going to be a relationship between those two. Then lastly, we have an identifier. The purpose of an identifier is to uniquely identify each instance or occurrence of the entity. So it's going to be unique to each individual instance of said entity. So for example, with student, what do you think the unique identifier would be for student? ID, that's exactly correct. Damien, right? Yeah, so it'd be student ID. So it's going to be whatever your unique number is. You could also use net ID, something to that effect, where it uniquely identifies each instance of a student. If we have two students with the same ID, we have a problem. That's not going to happen. Now, another term for identifier that you're going to see is primary key, and that's probably what we'll use throughout this unit. So any questions so far? Did I lose anyone yet? That's good. Certainly feel free to ask any questions as we go. But within this, there's really two major things we want to have for our data models. We want them to be well-formed, and we want them to have high fidelity. So when we're talking about a well-formed data model, we're saying that all the business rules are followed. So if the business rule says that students take one and only one course, we have them take one and only one course. We also make sure that there's no amount of ambiguity. So if we had ambiguity, it'd be things like having some sort of an attribute that means nothing. So imagine if our student attribute, instead of having things like first name, address, phone number, imagine if we had student 01, student 02, student 03, and each of those were our attributes. Is that clear? Do you know what student 03 is? You do not. So you want to make sure that you have meaningful names, that stuff is logical, and that it follows the business rules. That's a well-formed data model. That contrasts a little bit with high fidelity. So with high fidelity, we're more focused on the quality of the data model. So is it something that is logical? Is it something that accurately represents what we actually have? So the Bookish is the example. If we have a many-to-many relationship inside of what the ideal data model should be, if it's a high-fidelity data model, it will have that many-to-many relationship present, even though inside of a well-formed data model, that's going to violate a construction rule. So we just want to make sure that whatever we actually see is represented well within high fidelity. So that's kind of the distinction between those two. They're very similar. They're quite related. One of the homework questions, I think not unit 3, but question 3 this week, asked that very question. That's what you would say. So pretty much that's what we're talking about. We're talking about well-formed and high-fidelity models. So as we go throughout this, we're going to start off with a very basic model, and we're going to critique it. So maybe I had a model on the board, and it just had student and class. And someone could say, well, there's a problem with that, because multiple students could take multiple classes, and students will take multiple classes. That's a many-to-many relationship. So we would have to, go throughout this and make improvements. So as we go, we're not going to have a perfect model the first time. So what we want to make sure, though, is that our final model is accurate. It represents things, it is logical, and it's well-formed. So here's an example of that. What we have here is we have a basic entity relationship diagram. So we have 3 entities here: nation, admin unit, and city. Now, if you're wondering what admin unit is, it's basically a state. So, in the United States, we have 50 states and a couple territories. So those would all be administrative units. Nation, of course, would be the United States, and city would be a city within a administrative unit. So right off the bat here, can anyone tell me some problems with this? Oh, by the way, so this asterisk right here denotes the primary key. So in other words, city name is its primary key. Means that inside the city table, the city name will be unique. Is that realistic? Are there 2 Philadelphias? At least 2. I got really confused when I first moved down to Mississippi. Someone was saying they're going down to Philadelphia for the weekend. I'm thinking that's a very long trip. I wonder why you're going that far for anything. And they were confused that I was confused. I'm thinking, why are you going to be traveling 8 or 12 hours to go to Philadelphia? They're like, it's not 8 or 12 hours. I'm thinking, well, then you got a different sort of car than I do. But anyway, so it's not a unique identifier. So that's the problem. What are some other problems? Is this well-formed? So it's not quite well-formed because what is this one-to-one identifier right here? You always want to label your one-to-one identifier. City has a nation. Nation has only one city. That doesn't make sense. Nations have a lot more than one city. So that's another problem. Can anyone see any other problems here? So what's the problem with that? I would assume it means the amount of like square miles or whatever. I'm not entirely sure about that. Beckett, right? Kelly. What's your first name? AJ, right? Gotcha. Yeah, so, certainly there could be a lot of problems. This is a pretty ambiguous model. So let's see what they say about it. Can a nation have more than one capital? Certainly, there are some nations that do. Can a city be a capital in more than one state? I have no idea. Let's see what they say. So they have some different pictures here. Looks like we have South Africa. We have several different capitals there. Johannesburg, some of these others, Cape Town. Then we have some other examples here. This is, I believe, I'm not a geography person. That's India, though, right? You know, I'll be honest, I'm not entirely sure what this is representing where it has the red, but I'm assuming it's a violation to one of these two rules. So let's just go with that. So we want to take that first model we had, we want to revise it. So we're going to do some quality improvements to it. So now we've correctly labeled the nation as one to many cities, but a city is going to be the national capital of one and only one nation. In other words, if you had a city, it can't really be the capital of two nations because it can only be inside of one nation at a time. So that's what we're seeing here. Then we also added, so we have administrative unit city. So before, you know, the city name was our identifier. Now we have city ID as the identifier instead. And that allows us to have a unique variable be or a unique attribute rather, be the identifier. So city name in and of itself is not unique to a city. It could be, you know, are there other Starkvilles in the world? I'm not aware of any, but I can guarantee you there's other Columbus in the world. And there are other, probably some other West Points. I know there's a West Point, Georgia. I believe there's West Point, Alabama as well. Now, ironically, the West Point, Mississippi is pretty east. I don't think it's the westernmost point in Mississippi. Someone will have to double check me on that, but I'm pretty confident about that. So basically, what this is showing is that we're going through here and we're making sure that we have a better relationship between these. So previously, you know, we had the administrative unit having one to many cities, a city belonging to one and only one administrative unit. Of course, we also had this one-to-one relationship up here that wasn't identified. So we've just corrected a lot of issues with it. Any questions about this so far? Let's go ahead and talk about this from the concept of having a marriage relationship. So apparently the book made a pretty bad joke about, you know, if you have a different, you know, family problems, one way to kind of identify what's going on is to use a relational model. That's a pretty bad joke, so I won't certainly make that. But that's what we have here. So we have a man, we have attributes about the man, and is married to one and only one woman, we have attributes about the woman. Now, what are some problems here? Man, date of birth, man, first name, man, whatever O name is, man, last name, woman, date of birth, woman, first name, woman, last name. Are we repeating information? So we could probably generalize this a little bit. So let's see how we would do that. So instead of having man and woman, we're going to simplify this to having person. So now we have, you know, the ID of the person, which I'm assuming is going to be like a social security number, something that's unique to each individual. We have date of birth, first name, last name, and gender. So we can get all the same information in a simpler model. Now what we have here is we have a recursive relationship. So a person is married to one other person. Okay, that's what that means whenever it's going to the same entity. It's called a recursive relationship. So in this case, we see person is the spouse to another person. Now the book starts getting a little bit complicated with some of the different types of marriages. We're going to skip a couple of them because I don't even understand what's going on in terms of the, I understand what the model is representing. I just don't understand how that would actually play out. So we're going to skip some of these. But this will certainly go ahead and solve a lot of the problems we could have. So will there always be the case that someone is only married to one person in their entire life? So people can get divorced. People can get remarried. They're not going to be limited to only marrying one person in their entire life. So to solve that, we would have a marriage entity. So instead of having the recursive entity where one person marries one and only one person, we're going to solve that by adding in a marriage entity. So a person can have more than one marriage, but a marriage will belong to one and only one person in this specific instance, because what we have here is we have this plus sign on each of these. And what that plus sign means is that we're taking the ID from whichever entity it's pointing to. So in this case, we're taking the person ID and we're adding inside the marriage ID. So we have the person who's inside the marriage, and we have the begin date. Those are going to be the two primary keys. It forms a composite key for the marriage entity. So what we have here is we have the ID of the person within the marriage. So, you know, could a person get married on the same day? Yeah, I'm sure there's a possibility, but you know, like I say, the book's going to continue to go and solve some additional problems that I don't think you're likely to run into. So we're just going to say this is a well-formed model at this stage because it accounts for the fact that a person is married to another person, and that this plus sign right here, just a reminder, means that the ID from the other entity that is closest to it, or not closest to it, but is directly pointing to it, is going to be encompassed within it as well. So any questions about this? And it starts throwing in children to the mix, and it starts getting very complicated. So the next thing it does is, what about couples who are not officially married but have cohabitated? Again, we're just going to keep it relatively simple. So now let's talk about a library book. Okay, so what we have here is we have an entity for library, and the only thing we want to know about the library, what is its name? Can two libraries have the same name? They could. It's unlikely. So, you know, it's not going to be something we're going to be concerned with at this particular stage. Then we have information about a book. So the library has one to many books. A book belongs to one and only one library. I don't really like how the textbook doesn't include the minimum and maximum if it's a one-to-one. I wish it would. We'll see examples of that a little bit later on. But basically, we see that a library has one to many books. And within the book, we have the call number. Where is it located within the library? We have the ISBN, we have the book title, and the due date. And then, you know, we also have people who loan out the books. So we have the borrower. So the borrower can have one to many books. A book belongs to one and only one borrower. So within the borrower, we have the borrower ID as a unique identifier. That's probably going to be the library card number. Then, of course, this ... means we have additional attributes about the borrower that we're just not including here for the brevity's sake. So, this is not necessarily well formed because, for one thing, we're missing attributes. For another thing, there's a big problem here. Can a library have multiple copies of a book? You know, it certainly wouldn't be a very good library if you walked into it and you picked up the book and it was the only book copy that they had of that particular title. So we want to go ahead and add in a copy entity. And what we have here is we have a relationship where you have the book, instead of having one singular copy of the book and repeating that information throughout the table or throughout the database, we're now going to put that within a copy. So each copy is going to have some sort of barcode number associated with it to uniquely identify each and every occurrence, or instance rather, of the book. So that's all we're doing there, is adding in another entity here. A borrower can still have one to many copies that they're having loaned out to them. A copy at one specific time will be lent out to one and only one borrower. So any questions about this? And again, as we see here, a copy is one and only one book title. It wouldn't make sense for a copy to be several books, unless we're talking about a collection, which again isn't really, we're not going to cover that too much. We want to keep things relatively simple. So a book is going to be used in one to many instances of a copy. So we can have a book within our library that we only have one copy of. We can also have 10 trillion copies of a single book. So that's just what we're representing here. Does that make sense to everybody? Okay, let's continue on. So the whole issue here is that we have retailers, and how do retailers identify their products? Well, most of the time they're going to use the universal product code, which I believe is a 12-character, could be 14 or 16, but I believe it's 12, uniquely identifies each and every product. However, it does not identify each and every instance of the product. So if I had 2 cans of peanut butter, assuming they're the same brand and all the same, sort of product that they have the same universal product code. So what retailers often do is they take inventory. They see how many counts of a particular product do they have. So this would certainly change if each of the identifiers for whatever product we're talking about were unique to the actual product itself, as opposed to the larger category of product. So what are your thoughts on that? Should the thing be unique, or should it be just unique to the product classification? Any thoughts on it? Yeah, certainly. In cases of shrinkage, it would make things quite a bit easier to identify. Would it be worth it? Certainly would. William, right? Ben. You go by Ben? Gotcha. Yeah, certainly. That's something to consider there. Any other thoughts? Anyone ever worked a retail job like that before where you have to take inventory? What do you think about it, Sam? Yeah, so it'd be in that case, it'd be very challenging if you had to find a specific unique identifier for each individual product. Wouldn't you think so? Yeah. Yeah, it'd certainly be a challenge. So we'd probably want to, avoid having anything that's going to be too unique. Now, it's also going to vary depending on the cost of the product. So imagine we had a product that cost $10,000. You think we want to keep more track of that than a 30-cent pack of gum? We probably would. So there's no right or wrong answer. This is all going to be determined by business rules. What does the business want? Do they want to have a unique identifier for each and every product, or do they want to have a unique identifier for each and every classification of product? Really two different perspectives there. So let's kind of go on and do some additional ERDs here. So what we have here, I'm not sure why it calls it history. It's more about an employee relationship. So we have an employee, and the employee has an ID as well as several other attributes of interest. So they work for one and only one department, which of course department has the department name. It's going to be unique. If you have two departments called the same thing, what does that mean? Probably means there's a lot of redundancy within the organization. We want to avoid redundancy. Redundancy is inefficiency. Inefficiency means we're losing money. So the point of the business being to make money, we would not want to have any sort of redundancy. So we have department identified by department name, and then department belongs to one and only one division. So each division has a unique name associated with it. So there's some issues with this, some potential issues with this. An employee has one and only one department. Is that a problem? Jarek, what do you think? Is that a problem for an employee to only work for one department? Yeah, certainly. So it's a lot of cases, you won't only be able to working for one department. You may be working for several departments. Think about an academic institution. A lot of faculty have appointments in several different departments. There's lots of cases where one employee is not going to be limited to one department. So how do we go about solving this? Well, we'd add a position. So employee has one to many positions. A position is held by one and only one employee. Then, of course, on the flip side, a position belongs to one and only one department, but a department will have one to many positions associated with it. And who remembers what this plus sign means? Who can tell me what that plus sign means? So earlier on, we talked about how that actually receives the primary key. So can anyone tell me what the primary key for position is? Okay, anything else along with that? So yeah, employee ID, and one more thing. That's exactly correct. So what this plus means is that it's going to obtain the identifiers from this entity because it's the one that has a direct relationship with it. And then the same thing over here. So we have a plus, that means it's going to get the identifier or primary key from this entity and put it in here. So we have a composite identifier, a composite key comprised of 3, in this case, primary keys. So that's what that's referring to whenever we have those plus signs. It's taking the primary key or primary keys, if there are multiple primary keys within the entity, and adding them in as identifiers. It's a confusing notation. In my opinion, this is not well formed because it's kind of confusing as to what's going on. On a test, I'll do it a little bit differently. But for now, that's what that refers to. So does that make sense to everybody? Okay. So of course, position is going to be unique to the department because part of the unique identifier, part of the primary key for position is the department name. So, if you have one department name inside the entity, inside of each instance rather of the entity, you cannot have multiple departments with that. That's why it's a one-to-one relationship. Same thing with employee. So employee has at least one position. So they could have multiple positions in this particular model, but they have a minimum of one. So inside of that, they're going to be inside the position. So the position is going to be unique to the employee. Does that make sense? All right, let me know if there's any other issues. Again, this gets pretty complicated. For now, we'll just call this a well-formed model. Now we have a different problem. So we actually have a 3-way relationship here. And that gets a pretty complicated model. This is a correct model. There's nothing wrong with this model inherently. However, can anyone tell me what's going on in 15 seconds or less with it? Probably not. It's quite confusing. So basically what's going on is we have an aircraft, we have an agent, and we have an airline. These are our 3 primary entities here. And within that, there's a bunch of many-to-many relationships. So an aircraft is used by an airline. That's a many-to-many relationship. So we added in an associative entity here. But the problem is we have 3 of those relationships. So we want to simplify things. If you submitted this would be a correct answer. There's nothing inherently wrong with it, but it's just very complicated. So we can actually greatly simplify this. So instead what we're going to do is we're going to have aircraft, airline, and agent, and they're all going to come together, and they're going to form a lease. So the lease, in this case, has a very composite primary key. Can anyone tell me what the composite key for lease would be? Okay. And what else? Okay. And what else? Okay. Anything else we want to have inside of here? That's exactly correct. And who said start date? Was that, let's see, Maxwell? Just want to make sure I'm giving everyone credit for participation. Yeah, so this is a great way to do it. Who prefers this way? Anyone prefer this way? It's okay if you do. Who prefers this way? Certainly a lot more people prefer the sort of a simpler approach to this. So we're just taking the same information. There's no difference in information that we have. We're just combining this into a singular sort of relationship, as opposed to having it expressed in 3 separate sort of associative entities there. So again, there's 2 ways to do it. These are both correct, but this way is just a little easier to understand. All right. So now let's take a look at this here. So we have an employee. They're doing at least one thing, but they could be doing multiple things. That's the activity. Project has at least one activity, but it could have an unlimited amount of activities. Of course, the activity corresponds with one and only one project, and the activity also corresponds with one and only one employee. I think the activity corresponding with one and only one employee doesn't really make a lot of sense, but we'll go with it for now. And then lastly, we have activity has one-to-many daily work, and daily work has one-to-one activity associated with it. So not the most logical model, but again, if a business rules specify to do it this way, this is the way we're going to go about it. So what we have is we have the planned hours belonging in the activity. So let's say the activity is someone list me off an activity that we would have. So we have a project, something with a start and end date, and the project could be anything. Someone list me off a project. Okay, building an engine. So that's the project. And then what are some activities within inside of that engine building? Do what? Okay, so let's say let's just use the activity being acquisition. So we could call it lots of different things. We're just going to call it acquisition. So we have some amount of hours that's going to take. How long does it take you to acquire parts for an engine? Couple months. Okay, so maybe in hours that could be, let's say 200. So daily work, we're going to have the actual hours that we're spending. Anyone see a problem with this? So the potential problem is that planned hours could be expressed in a different unit than daily work. So if the unit goes beyond 1 day, we're talking different units. It gets a little complicated. So a different way to approach this would just be to move planned hours outside of activity and put it inside of daily work. That way we have everything expressed in the same units. Again, this would depend upon the business rules for the data. So whatever the business rules say is what we're going to go with. Let's kind of shift gears a little bit now and talk about cardinality. So we have cardinality and we have modality. When we think about modality, what we're saying is something mandatory or is it optional? If the modality is optional, it means that the minimum amount is going to be 0. Then we have the second number here, that's going to be the maximum amount. So the cardinality comprises both the minimum and the maximum, whereas the modality only kind of encompasses that minimum amount. So that's what we're seeing here is we're seeing a case where we have a one-to-one relationship. So basically, the way the book defines a one-to-one relationship, unless it's specified otherwise, lease has one and only one aircraft associated with it. So that's what we're kind of seeing with a one-to-one. They don't use the actual things. I'm going to upload something into Canvas where we actually go through each and every symbol that you could see. I think it's a more clear way to describe it. But again, slides come from the book. So that's what we're seeing here, is we have cardinality where we're defining the minimum and maximum, and then we have the modality where we're just defining the minimum amount. Is this mandatory or is it optional? So does that make sense to everybody? So basically, that's just what this is saying. Same thing here. Let's take a look at this. So here's an example of what I'm talking about where you have the minimum and the maximum defined. So as we go further from the entity, that's going to be the minimum. Now, what did I just say we could also use to refer to the minimum as? It also starts with an M. So modality is also the minimum. Saying, is it optional or is it mandatory? That's the modality. So that's going to be expressed a little bit further from the entity. So in this case, this little 0 right here, what does that mean the modality is? It means it's optional. We don't have to have an instance of that specific relationship. That corresponds with or that contrasts rather, when we have the one-to-one relationship here. So we have 2 vertical 1s, meaning that the maximum instances of that relationship for the specific thing there going to be 1, and the minimum are also going to be 1. So in other words, stock must have one and only one nation associated with it in this example. Now, if we contrast that, we say nation can have 0 stocks, or they can have an infinite amount of stocks. So we can refer to this crow's foot as we refer to it as many. We can refer to it as infinite, unlimited, whatever you want to call it. Doesn't really matter. Just know there's no maximum amount associated with it. So that's the cardinality and modality. What do you guys think? Do you guys like the notation where it doesn't really give the max and the min, or do you guys prefer this notation? This right here? I think it's a lot more clear as to what's going on, in my opinion. But different people have different ways of doing it. So let's just kind of go through it. Let's take a look at this as well. So what we have is we have a sale has one-to-many line items, and item has 0-to-many line items associated with it. So let's just kind of go through and see how we would actually read this. So the first question here, can a line item exist without a sale? So we look at line item, we see, can it exist without a sale? It cannot, because it has to have that minimum amount of 1. So that's going to be the modality. Now let's contrast a little bit with, can an item exist without a line item? So we go to item has 0 to many line items. So what are we going to say there? Can an item exist without being associated with a specific line item or any line item? That's exactly correct. It can. Everyone see how we got those two answers? You'll certainly see some questions like this on the exam, so make sure that you're familiar with that. Okay. So again, this is going to be one of these recursive relationships where we have a department's boss up here. We're defining what that is. So employee can be the boss of 0 to 1 departments in this case. So we can more clearly see it down here. 0 to 1 departments. Department has one and only one boss. Then, of course, we have just the standard relationship between an employee and department, where we see that employee belongs to one and only one department. Again, that's a business rule defined by the business. And department has 0 to infinite employees associated with it. So does that make sense to everybody? Again, on the test, you'll see things formatted a lot more similarly to this than you will to this. Just kind of a heads up there. So certainly make sure that you can read what these are. And again, I will post a little guide in Canvas that kind of identifies the specific symbols in a little bit more detail. So here's one with the monarch. So we have another recursive relationship where the monarch has a relationship with the monarch. Doesn't really seem to make a lot of sense. When you think about it, it's pretty logical. So what we see is monarch has a succession. So there's someone who comes before the monarch, and there's someone who will come after. But that's not always going to be the case. So the modality for both of these sides of the relationship is optional. Why would that be optional? Was there at one point or another a first monarch? So this side right here, at some point, someone had to be the first monarch. I don't know enough about any sort of monarch history to tell you who that person was, but certainly at some point or another, there was, in fact, the very first monarch, or whatever monarch you were following. So the monarch is succeeded by 0 to 1 people. Then, of course, the monarchy succeeds 0 to 1 person as well. So that's what we're saying here, is that for each of these things, we don't have to have one before, we don't have to have one after. We probably would in most cases, but we want to make sure that our model correctly identifies all cases. So here's just another example of that. So basically what we're saying is it mandatory or is it optional? And there's a lot of different ways to go about this. We're going to cover some of this stuff when we get into the actual building tables and building these relationships, so don't worry about it too much. Now, within entities, there's several different types of entities. So we have independent entities, dependent entities, associative entities, aggregate entities, and subordinate entities. So let's go through each of these. So when we think about an independent entity, what really makes it stand out is that it's likely not going to have a composite primary key. So in the case of a nation can stand alone. It doesn't require any presence of anything else. We have a nation's name. Nations' names are not repetitive. You're not going to have 2 United States of America. You're not going to have 2 Great Britons or United Kingdom. So that's going to be something that stands alone. The Bookish example, it's going to be something that the client immediately thinks of when they're talking about what's important to what they have. Same thing with a stock. A ticker is unique to a unique stock. So if I list off the ticker of MSFT, what is that the ticker of? Microsoft. If I listed off the ticker of, something like, various firms, we would certainly say it's going to be unique to that. So because it has that unique primary key, that's just a single attribute. So the primary key is comprised of only one attribute. It's an independent entity in most cases. So that's what we're kind of seeing there. Now this kind of contrasts a little bit with a dependent entity. So a dependent entity is going to be one where we basically have to have something else present in order to properly form and properly identify what we're having. So in the case of city, we would have to have some sort of unique attribute that can define each instance of city for it to be a truly independent entity. Now we could use zip code for city. Zip codes are not going to repeat. What's the problem with zip code? Do different countries use the same zip code system? Probably not. So we could potentially get around it, we could potentially not. But in the case of this, the city name requires the region that it's in as well. So for example, if we're talking about the city of Starkville, do we just say Starkville or do we say Starkville, Mississippi to identify Starkville? So that's what this is kind of talking about. It's dependent upon another entity to fully form and identify its relationship. So in other words, we're going to have probably some sort of composite primary key here. Now let's contrast a little bit with the associative entity. In the associative entity, we're going to have a many-to-many relationship. We're going to break it up by adding in another entity in between those two that basically takes the attributes, or specifically takes the primary keys from the other two entities, two or more entities, I should say, and it forms those into a composite key. So in the case of department or position here, we have a department has many employees, and an employee can have many departments. That's a many-to-many relationship. We just add in a new associative entity between those two. In this case, it's called position. And because we have these two plus symbols here, we know that the primary key for position is begin date, department name, and employee ID. So that's what we're seeing there for an associative entity. That's all we have to do. So it should make a lot of sense. Then we have an aggregate entity. This is where we take an entity, and in order to form it, we basically comprise several different attributes together. So the Bookish example of addresses, if we want to have an address entity, we would have a lot of different things to form the address. So there's not one single line of an address that you can say, this is the address. You have to take several things and combine them together. That's all this is saying. Does that make sense to everybody? All right, we've got one more thing here, subordinate entity. So we have a kind of relationship here between animal and specific species of the animal. So we have animal ID as the primary key for animal. We also want to know the animal date of birth. Then, of course, you would have different types of animals here. So you'd have a sheep. What's a sheep? A sheep is an animal. In this case, we want to know specific things about that sheep. We want to know how much does its fleece weigh. I'm assuming that's sheep make cotton, or no, they make wool, right? Yeah, I'm going to have to edit out that part about sheep making cotton. That's not how cotton grows. But yeah, I'm not really going to edit it out. That's a lot of work. But anyway, you see the point. So we want to know the fleece weight for the sheep, but we don't want to know the fleece weight for the horse. So for the horse, we want to know furlong speed. What is furlong speed? Does anyone know? I'm assuming it's the speed of the horse. I don't know exactly either. But certainly, knowing how fast the horse goes is very important. Any horse racers in here? Any people like to gamble on horses? Well, if you did like to gamble on horses, you would certainly want to know how fast the horse is prior to gambling. Of course, I'm not recommending you go out and gamble on horses, let's be clear, but that's what that's referring to. So this is going to inherit the attributes from whatever the parent entity is here. So in this case, horse, we also want to know the animal ID and date of birth of it. But in this case, we're going to add in the furlong speed only for the specific things that are actually horses. So imagine we had a farm, and we had 5 pigs, 5 sheep, and 5 horses. So we would actually only have the fleece weight for the sheep. But we wouldn't have the fleece weight for the pigs. Do pigs have a fleece? I've never seen a hairy pig. I'll say that. They could exist. I'm not aware of them existing. So that's what this is saying, is that we're going to have different instances of the larger sort of parent entity, but we're only going to focus on this kind of subordinate entities for the specific attributes. Does that make sense to everybody? So it's kind of like you have a parent-child relationship in program. It's the same concept. We'll kind of go through some of these hints. Basically, you're not going to start off with a perfect model. As you go throughout this, you'll realize problems with your current approach. Maybe you'll be meeting with a stakeholder, and they'll say, well, what you have right here is good, but it doesn't represent our business model very well. So they would give you different business rules. They give you some things to change. And, that's not necessarily a bad thing. In fact, in a lot of cases, it can be very good to have that ability to change. So certainly, you'd want to make sure that you have identifiers that are going to identify each and every instance. They're not going to have any repeated identifiers. If you have a repeated identifier, that's a big problem. You need to address it. Same thing with if you have something that doesn't have an identifier. That's also something you need to address. Then we talk about this. It's very important that the attributes themselves are named logically. So if we had something like this, where we had an employee, what if we also had client on here? It could make sense that we have employee ID, we have imp first name, you would have imp last name, that sort of thing, to uniquely identify each attribute so that it's not getting confusing with other attributes. Imagine we had client, and it also had a name. If we called both of those attributes name, that could get very confusing. So to avoid that, we could just put a little prefix for each thing that's going to repeat throughout the model. Another approach we could take, we just want to make sure we're being consistent with our naming. So if we have something like employee naming, we would also have something like maybe CLI name. You know, CLI for client, just like we have EMP for employee. Just want to be consistent there. Here's a little bit of stuff about postal code. Not going to go through this too much. Just know that a postal code is going to be comprised of some integers. And, you know, there are some other formats, like the full zip code here, where it's going to be comprised of about 10 characters. So this little dash symbol, hyphen, whatever you want to call it, is not going to be an integer. It is instead going to be a character. So when we talk about data types, this will make more sense. For now, I just want to make sure that everyone understands how to model these relationships. So a couple things more about data modeling. It's okay if you have an entity that only has one instance. That's okay to have. There will be some cases in which that'll be the case. Imagine you had information about a company, and you're only focusing on your one company. You're only going to have one instance of the company entity. That's okay. So, you know, just make sure that your namings are clear. You're avoiding any sort of things that have the same meaning. That could be a problem. It could certainly have some confusion. Yeah, so that sort of thing. And again, you know, whatever you decide to do, make sure that you consult with your stakeholders. Make sure that it fits within what they need it to be. Looks like we have some stuff about meaningful identifiers. Just make sure that the stuff makes sense. I've kind of gone through that. Here's some things to kind of think about here. Make sure that you're, to be successful in this process, immerse yourself in what the business wants to do. You make it challenging. You don't just focus on one aspect. You instead focus on the larger picture. You kind of make things sure that the model is generalizable. You test it. You see what sort of limits does it have? What sort of problems? Can we address those? You integrate all the feedback, and then finally you complete it. So that's just kind of what we're talking about here. Just to wrap things up, we talked about the high fidelity model. It's going to make sure that it accurately represents what we're trying to represent. It's very attractive. It doesn't have any sort of problems with readability. Handles all the exceptions very well. Of course, we talked about identifiers, making sure that they only refer to one instance of the relationship. And lastly, we want to ensure that we have the data modeling skills to make sure, you know, this is going to take time. So you're not going to be able to do a perfect ERD the first time. When we pick up Monday for class, I'll actually have some different ERDs. We'll model them together. You know, right now, if we did it, you probably wouldn't get a perfect score on it. You may not do things 100% correct. That's okay. So by the time we have exam 1, which will be, I believe, Friday, next Friday, not this Friday, you should be in a very good spot with that. So any questions about today? All right, guys. Well, I hope you have a great day. I will see you all Friday.